if I'm doing this and I have a block of tissue and I take 6 micron sections throughout that block, there's technologies out there that allow me to sort of reassemble that virtually into what would have been a 3D tissue. Is that the sort of approach that we can take with brain tissue as well?
It's kind of aspirational. It would be nice, and people ask for it all the time. Can you basically image through the whole brain and then reconstruct it in 3 dimensions so that we know everything? Well, we do, I think, as good a job or even better as anybody else can, regardless of what other people promise. And so we take great care again to know exactly as we section the brain. It's like we use something akin to a deli slicer, section it up, and we track all those sections, and then as we image those sections, we know in if you call this the Z dimension, we know in the X and Y dimension where every image that we've taken is coming from. So from that point of view, we can, by mapping everything onto a canonical brain atlas, we can then tell you exactly in X, Y, and Z where the brain structure or cell or whatever has come from.
Okay.
But it's not really indexed. It's what's more useful than an XYZ coordinate is this. It's from this particular brain structure. I mean,
Okay.
right? If I can give you an XYZ coordinate, but it's meaningless unless it's tied to a brain structure.
Right. Okay. I imagine that requires a certain amount of precision in handling the sample as you're trying to, prepare it for slicing and staining. Am I right?
Yeah, absolutely. And again, these techniques have been worked out over decades in different academic neuroscience labs, and it involves very carefully tracking, at the right level where the sections are coming from, and then within a section where exactly you are relative to a reference atlas.